Hello, everyone. I hope you had a nice lunch. This will be a tough audience, so I will try to sometimes raise my voice, and you will be like, "What is going on around?" And no, everything should be okay. Even though this is a talk about some internals, we will see some code in other languages. Don't be scared, and I promise you, just enjoy the ride. And maybe after this talk, you will learn new things. That at least is my goal. Uh, as they said, my name is Cristian. If you want to find me on social media, you can send me a message after this complaining why my talk was so bad or anything. You can just send me a message. So, languages. We are all here for Python, right? So, I am originally from Chile. There we speak Spanish. Many of you might be familiar with Spanish, of course. I live in Germany for many years now. I tried to speak German there. We are here in Greece, but the talk is in English. So languages, it's something that is very intrinsic to all the stories, right? And not only speaking ones, but also programming ones. One important thing that I noticed, I really like this illustration, is that I was trying to see, do we have any close kind of like relationship between Spanish and Greek? Well, if you want to see with the languages that I was talking there, and they're very separate. So I thought, okay, well, makes sense, different alphabet and different things, but there is a lot of influences. So I searched around. Yeah, I'm an old person, so I didn't use any AI. I just searched on DuckDuckGo, and I was looking at a few words. Maybe you would say, no, that's wrong. That's not a Greek word or whatever. But I was trying to find that it's interesting that we have so many words that are super similar to you. So if I say drama, idea, filosofía, you will say, yeah, I know what you mean, right? So it's interesting how languages, even if they are not based on the same common language, they influence each other. And at the same time, languages evolve. Don't get excited. We are not starting yet. So let's switch. So for me, at least the evolution that I have seen from Python is that initially it was only a scripting language for playing around with things. And then with the big war started between Ruby on Rails and Django and all the other things, Python became a really important language for web development as well. Then I saw, what you may be already also listening this morning in the keynote, the boom that Python has in science-related things. And now we can say literally that Python is in most of the scientific projects, right? And recently, of course, we all have seen the evolution of AI and people using it. A language is the most popular, Python is the most popular language and everything. But we are still about to see what is next, right? So we have all these milestones, but what is next about it? And I believe that it will be related to the extensions and the way that we are using Python nowadays. So what is helping the current popularity of Python, in my opinion, is that if you go and check any of the famous projects, for example, I don't know, PyTorch, you will see there, maybe very small, but maybe you can read, there is a large portion of C++, C, Objective-C++, and other weird languages besides Python. If you go to more modern modules like Pydantic, they rewrote the core completely in Rust, so you see a lot of Rust there. There is this random database that I learned from it last year, also written mostly in C++. And even UV, that people also might know recently because of all the popularity of using it in the Python ecosystem, is mostly written in Rust. So, right? So we are seeing that Python popularity, it's kind of very tied to other programming languages. So why should we use other programming languages? Well, first of all, familiarity with new technologies. I've said that it's very cool when you have something that is not available in Python, but maybe is written in a different programming language, you somehow can glue it together, right? You also get in touch with old software. When I was studying also, I touched a lot of Fortran code. Who here has touched any Fortran code? Don't worry about being a developer or anything. So it's interesting to see that you can bring all this old software to a current state with the help of Python, right? So you reach other technologies as well. You want to use other programming languages because Python is slow. That maybe this is something that a friend of you told you already. And one of the interesting things is that, to many people's surprises, is that compiled languages are faster than interpreted ones, right? So how many programming languages are there? We will not talk about all of them, of course, because if you go to the Wikipedia page, it will like go crazy about all, like even for each thing. So we will not talk about all of them, but only a few. And before starting, maybe who here was in the documentary the other day? Can see some hands? Okay, so most of you will be familiarized and will immediately recognize this code. I always like to show it because it's good to understand where Python is going now. Because this language, if you didn't know, it's ABC, which is Python inspiration. And you can see some Python kind of bits inside. Maybe the if, the indentation, maybe the for loop. That just looks very simple there. So you see how Python was born from these ideas modifying a few things. So the evolution of languages is something that we cannot stop, right? Well, if you want more reference there, of course, it was inspired in ABC. So to understand Python, I usually like to do this first impressions of which Python. If you saw yesterday's talk, for example, from Lisandros, he was mentioning that there are a few interpreters, right? So this is only a bunch, but there are many more. And there are Pythons written in many languages, in Java, in Rust. There are like reductions, there are forks that some people use. And it's very interesting. So for the sake of this talk, at least when I say Python, I'm talking about the standard implementation with C Python. So for understanding C Python, or the world of extension, very briefly, if you want to extend C Python, you go to the documentation. It's a very nice page, in my opinion. And I read it. I understood many things. You can go there, and there's even some snippets. You can try it out with. So if you are brave enough to touch C or C++. In a nutshell, creating this module in a different language like C has only a few parts. Like first you have, the core mechanisms that you want to have in your program and you want to expose. But also you have to define all the methods that your module will have, the module itself, and then initialization of that module. So if you want to write your first extension, this is the most simple thing that I could figure out. I know it's a different programming language. Don't be scared. If you see there is one string declaration with some documentation. Afterwards is one function called simple hello that just returns a value that says hello from CPython. Then you have what I told you, the module definition, and then the initialization at the end. I know this, listen, it can be scary, but you literally can copy paste this thing somewhere with the help of another file, which is a PyProject or TOML. You can just create a wheel, install it, and execute it. Right? At the end of the presentation, there will be a link, so you can get all the snippets that I will be shown here, so you can try it out on your computers. And this is how you do an extension. So thank you very much. Now, of course, this is not the end of the presentation, because now it's the fun parts, like other programming languages, right? What is going on around? So it's tricky. There will be many things to learn. And again, try to get the main idea of these languages. You don't need to know everything by memory in order to start playing with them, because it's super essential for us to be aware of the existence of other programming languages. So the first one is something that is what I do for work. Mostly, or used to maybe at the beginning, that is writing C++. C++ is a language that is, some people hate it, some people love it, some people said now it's better, some people said it before it was better, but it's a language that is very old, and being old and trying to stay relevant requires for you to do changes. And also, if you are basing the philosophy that everything needs to be backward compatible and stuff, you need to make decisions, and there are keywords that look weird, and the code is very strange. But all programming languages can be also complicated as well. But we'll not go there. This is, again, the most simple snippet of C++. I hope everyone can read that I say, okay, they are doing some kind of import in other languages, and then a main function that prints hello world, right? It's a compiled language, so you need to compile it, execute it, that's it. So as I said, it's very easy to have, you can consider it like an extension of the C language, because now you have generics, functional programming, object orientation. It's also something that a language that still have access to low-level memory manipulation. And one of of course, the good thing is that the performance, efficiency, and flexibility of the language, it's something that it shines. C++, even if you don't like it much, is everywhere, like most people probably in the drivers of these devices, or maybe in your computers as a dependency of other things that you're running C++ applications and you don't know. So yeah, if you want to find some similarities, because that looks strange, again, super simple Python code that I hope everyone can understand. A class rectangle with a couple of methods, and kind of like I'm faking a main function there, how you can call it. And then you have C++ next to it. Okay, first thing that you might think, okay, there is a few braces there. It's very strange, semicolons, but I hope that you can kind of see the similarities and say, okay, I understand that that's the class definition, and then declaring the modules and everything else. So I hope it's simple enough for you, right? So there are a few features of this language that are very close, or I don't want to say inspired in Python, but inspired by many other languages like Python. For example, one is that since the previous versions, now you don't need to specify the type of variable. So I know now in Python, we are kind of evolving into getting to more like type specific for things, so things can be checked. But in C++, they decided like, well, in some cases, maybe let's have a special keyword that allow us to just to say whatever, and then at compile time you get the type, right? There is a different one. That for loop looks strange, but it's similar to what you have in Python. So hopefully you can understand. There are other things, for example, there that you can use the enumerate that maybe you use in your for loops as well. Well, they also implemented something similar, so you can have that as well. And last but not least, one of my favorite features, because it's very close to Python, which is that even a print that you can format in a way, you will say, of course, the language should have all this. Well, not really, because the ways of doing prints in C++ before this was very strange. But okay, that's for C++. There is a few things that you want to say for the summary. So as I said, widely used, sadly, they're having an official package manager. There's a few features from Python, and it can be very complex sometimes. If you're interested, I will leave you a video there for most of the language that I will talk about. So it's very interesting that you can to watch it. So Rust, again, who here is doing Rust code? A few hands, okay. Don't be afraid. It's fine. We're a welcoming community. We'll not judge you. Rust is terrible. No, it's not terrible. It's very simple as well. Compile language, main function there. You don't need to do this weird import, but you still need to compile it. And if you have visited the website, you can see that performance, reliability, and productivity are like the fundamental elements of the language, and everyone is so happy about it. So next side to side for Python, we have here like a list. I play around with the types, so it kind of resembles what we have on the Rust side, on the right side. And then you have a few operations, the print, everything should be okay for you to understand that Rust code. Similar example that we had before, a class with something like the first difference arise that we don't have classes in Rust. Well, maybe you're familiar with that, but yeah, they decided not to have classes, but still you can mimic the functionality of where we use classes and then implementing that specific structure and even extend it with some methods. So it's possible as well. So again, compared to C++, of course, maybe it's more simple, but you see a few weird things like this impl or fn for function or the ampersand around. But again, I hope you can understand that thing. So it's a few summary things is that, okay, ownership and borrowing are the best features of Rust. The tool, that it's an amazing tool, of course, as well. They can do everything with the same tool, growing ecosystem, but this is still an evolving language. If you are interested, I remember a long time ago, I watched this talk that is Rust for Python developers, in case you want to watch it afterwards, after the conference, of course. A different programming language now, SIG. Who knows SIG? Raise your hand. Knows. Don't worry, I will not ask you if you have written any code. Well, SIG also appear, not around the same time, but as I'm trying to solve the same problems. Here you have a little snippet of a hello world. I know for some people, it can give you some Java nightmares or C# nightmare with all these standard.ios, get standard.ios, writer, but trust me, I mean, there are a few quirks there, but the language itself is very good. So one of the things that they claim is that there's no flow control or hidden memory assignment. There are no macros. For some reason, the creator really hate macros in C. You have a few interesting features. You have a specific part of your code that can be related to metaprogramming. So you can have a compile time evaluation and then have some defer evaluation of some sections of the code. And the other very interesting thing is that they have inside a syntax to have tests within the same code. You can have a scope saying tests, open brackets, and then you have the testing in the same code. So it's very interesting and convenient. Again, similarities, just to put it side to side for Python. Again, the rectangle example, you see there that, well, you need to specify the type. It's a bit weird because also there is no classes here. You need to use structs. But then everything else should be okay. I mean, you see there is a weird thing that the return type of the main function needs to be a void, and then you have the exclamation mark, but don't worry about it. But at least you have the feeling of how SIG will feel, right? Summary, as I told you, they claim to be faster and more secure than C. I mean, I cannot ensure you that, but that's what they say. They have an integration, very interesting integration that you can import C libraries and then start to using it. So this is very valuable for companies doing, I don't know, very C specific things, that you can import these things without migrating everything, right? Should we pick up here? I don't know. They also have the framework for testing, as I said, the comp time thing, and I leave you this talk there, which is kind of like the main SIG programming language talk out there by the author. It's really cool. Watch it out. And yeah, there's another feature that also I really like, but I think that they were trying to remove. I don't remember if they removed that. It allows you to cross compile like with one line of code, which for C or C++ developers in the audience, you know how tricky sometimes it's a cross-compile thing. You have the toolchain and everything, but it was super amazing when I saw that and I tried it out. Often people, when I finish this presentation, decide they say, yeah, but you didn't talk about NIM. So I'm adding one slide for the people who knows NIM as programming language. Cool. Yeah. So when I saw it, it was like, oh, it's like a Python Bash weird thing, but it's cool. It's another programming language, new ideas. You have different ways of implementing stuff. But I don't have a comparison, just to give a shout out to the program because it's cool. I don't know, I discovered and it got my attention. And there are many other languages that, of course, I will have no time to do. So finally, how we can extend Python with them? For the first example, C++, let's remember what we had in C before. It's the same code. I haven't changed anything. And if you want to do it with C++, it's roughly the same because, you know, both languages are kind of compatible. So I'm just changing it. I'm including the string library in C++. I'm constructing a standard string from C++ and then returning that value. Super simple. Almost the same. So you can even modify that. Say, okay, I wrote some C++ code. And in SIG, it's a very, very, very simple approach. You first start to do the definition of all the objects. Then you need to start defining your own functions. Then you need to do the methods. And then you need to do the definition of the module. And then you do the initialization of the module. Very simple, right? And then, of course, you need the build specifics. So you cannot use setup tools. I mean, you use setup tools, but then you put inside some SIG command line specific stuff. And then you have your SIG extension. So then maybe on our scale, like, oh, you need to do everything by hand in this programming language? Well, you can, but luckily for us, there is one essential part, which is something that I work very close with, which are binding generator. So in a nutshell, little code that help you to not writing the whole thing by hand. I will take some water for suspense. Good, binding generator there. In a nutshell, you have some code, a magical box, and then you get your Python package. That's the most simplistic approach that you can understand what a binding generator is. The first one, if we start with C++ again, I think one of the most popular ones is PyBind 11. It's very cool because it's header only, so you don't need to have some sources around. It's inspired by the previous mechanisms to generate binding, which is from Boost, and a very famous library. Well, it's compatible with many C++ things and supports many compilers. This is the important part, the code. You have your very simple function, add two numbers. I hope everyone can understand that. And then PyBind 11 allows you to declare the Python module within the same code. And you see there, just put the documentation, the definition of the method, and that's it. You compile with those magical commands there at the bottom, and you have your first C++ Python module. I'll leave it at that. Very convenient, right? The same creator said, no, this is maybe too much. This is too bloated. Let's do reduce and only focus on a few specifics. So the person developed NanoBind, but again, super small, exposes types around, which is very convenient. It's inspired in the other one that I showed you before. And the footprint of this thing is ridiculously low. So it's an amazing binding generator. The code, very similar to what you saw before, right? But now you need to compile things instead of that weird command line with a few thematic things. The other one is something that I work close by because it's what I use in my company. It's also inspired in voice Python. We use it for Qt or Qt. I don't know if you know this framework, very old framework, again in C++, for the Python module. And you don't need to alter the library code. This is very important. For some people, they ask me, like, what do you mean by that? Large projects, as you might know, even in Python, imagine if now if I tell you, like, grab one of your biggest projects and you need to add only these 4 lines to each one of your files. Do you think that the rest of your team will be happy? No. So for that, the idea of this is mostly that you will not touch your code and you will write a file separately and the things will automatically be connected so you can leave your amazing library there on the left side, the test CBP, without touching anything and adding all these declaration. Very simple. You should give it a try. So now let's go. Yesterday in the lighting talks, some people were mentioning this generator talked about PyO3. Maybe you know PyO3. Who knows PyO3? Okay. Less hands than Rust, so it's interesting. So it's Rust binding for Python. It's a very cool thing because it includes many tools and also an interpreter inside, and it relies on a different project called Maturing. You see there is a very, again, simple Rust code. So you include some, do some kind of import of PyR3. You have your sophisticated function there, and then you declare the module like that. Most of the magic here is done by this weird pound key on the top of F and add. So if you see here, this thing is a procedural macro, and that's the thing that do the magic. That it's like a decorator in Python. So do things and generate some code that in order to generate the thing. And for Sig, the one that I was showing the example with the huge files and many lines of code, there is also something very interesting. So you have there they have a special plugin for doing PyTest. Again, they're compatible with CompTime, which is this feature that I told you before about having compile time deferred evaluation things. And they rely on poetry. That also maybe poetry. Has anyone used poetry? Keep your hand out. Do you like poetry? I knew there's always people, but I don't know. It's not a bad package. I mean, there's always like people that don't like things. But this is how you do it with Sig. Oh no, I lost Ege. Sorry, Ege, for being no, that's just kidding. So it's very simple. See, I mean, all those lines of code, but magically now Sig PyDAS will just require for you to add 2 lines, and then in CompTime, which is the feature that we were highlighting before, and that's it. You have your first Sig-based Python thing. So it's very convenient. See. There are many more, of course, binding generators. Just pick one language, go to Wikipedia, and for sure you have binding generation in that language. The majority of this is inspired in C because C is a very good language to glue things around. And from the case of C++, it's in such a widely used language. There, I don't know, I think last time that I did a table, there were like 15. And the process is sometimes, though these examples, of course, is to show you how simple the most simple case can be, but things can get very complicated. I will not scare you because it's after lunch session, so I didn't want to show you scary code. But in a nutshell, so you have why this complexity, or where this complexity comes from, is because you have specific concepts to the languages. What is a decorator in Python in C? Well, you would say, well, it's just a function that is inside a function or whatever. You can try to find abstractions, but there are things that you don't know. Like for the people that know C or C++, what is a void start in Python? You will say, well, it could be something, but it's difficult, right? So all these decisions, because people writing Python code, they don't want to write weird things from other languages, right? So you need to take care of all the specific concepts. Data types. For the people, the few hands that I saw about Rust, you tell me which one I need to use for declaring a string. Like there are like, I don't know, 8 type of things to declare like a characters kind of arrays. So which one of those do you use? It's difficult. Pointers, again, not all languages have pointers. So how do you make an abstraction out of it? Memory management. When you create something in a binding, let's talk about like memory. Who owns it? The Python module that you created or the C module under the hood? You need to make those kind of decisions like, oh no, for this specific one, now it's Python, so it can be garbage collected later or something. Or no, it needs to be alive by C. And threads, always problem with threads. Async, it's always problem with async because interpretation. The GIL as well, so even now if people remove it, this is still an issue because you need to stay compatible with those things. And uses the thing, I mean, I like that Python has new features, but at least as a library maintainer, is a very problematic feature for me because in a nutshell, this for many modules will mean like, oh, Python has no GIL. So now you need to implement your own GIL for your own things and processes that need to be like that. So yeah, you need to do logs and stuff, all those things that you were maybe learning in computer science classes that you thought never will apply. Well, you need to do it. So it's not fun. And there are many other things and complicated factors and here and there that you need to take care of. So going back to the current popularity of Python, as I told you before, rewriting Python code in a compiled language will make the performance go very, very crazy about it. But I really don't like, and usually the message of this talk is like, when you see these things, I try not to be surprised about, oh my God, I cannot believe it's faster because it's very obvious about it, right? So I believe that we should kind of rewrite this thing, not only because things will be faster, but just to uncover and try to bring more features to the language, right? So as I told you, I remember when a few Rust tools were around on social media and stuff, people were losing their minds, like, oh my God, I cannot believe it's faster. And everyone was like, of course it's faster, it's a compiled language. But anyway. So how difficult could it be then? I thought maybe I can be famous as well and have many internet points. And I thought a module that glove. Everyone knows glove from Python, right? Maybe you don't use it, whatever. And I thought, in C++, you have something called standard file system that you can iterate directories. So again, I took literally the same snippet that we had at the beginning, and then I said, instead of this printing hello, I will just mimic there the recursive operation of a glove to go around. And then I tried it out, and I had some numbers, and I have 1,000 directories with 1 million files in total. And I thought, okay, what if you use glove? That's the time, at least the base time that I had for things. If you use pathlove, if you're using pathlib, which is a very cool library, you get a lot of performance as well. And don't worry about the non-recursive one, is because I am transforming into a list, but the recursive one is the interesting one. And then I wrote it in Rust. It was so fast, and I was like, I can be famous, put it in PyPI, that's it. But then I did it in C++, and it was faster in C++. And then some people that remember in Lithuania told me, like, yeah, I know, because it's just the overhead of PyO3, because it's a binding generator, whatever. I said, fair enough, I will do it with a binding generator. And yeah, there is an overhead, but it's still faster than Rust. So then you want to say, why people is not using C++ there? Well, I don't know. But what not to do with this information overall is, as just to finalize the talk, is that please, when you solve one problem, not everything needs to be exposed to Python. Not every single feature needs to go around. You don't need to know all the programming languages, and don't try to force things that they don't work that way to work that way because of reasons. So don't see everything as a nail when you have so instead of a hammer, you need to try to understand that for our daily life, many of you, of course, are the software developers. You know that even if we love Python, there are other languages that bring us more things to do. So we need to embrace all the languages and try to have a proper solution. So as I said, we need a combination of programming languages for everyday thing. So what to do with this information after all then is just to help have the Python ecosystem to keep growing. And a topic that I think that I will not have time, that I wanted to talk about if Python has a successor, but I will just go, don't look at the slides, right? So yes, PyPy, ResPython, Mojo code, it's a really cool code, and by the way, if you want to check it out. But yeah, so with this help, I don't think, maybe the next things, in my opinion, will be based in a new extension or something that we can unlock from a new programming language that has an amazing feature and maybe want to expose projects to Python. And I don't know, maybe in a few years you will give a talk about and say it's like, oh, how people thought that Rust was a solution to all our problems, and now we have this programming language that was. So the final thing just to say is that extending Python with other languages keep the community very active, in my opinion, and also motivate some discussions that we're going to have here. I mean, you saw yesterday when I shouted Rust to the Lightning Talk, people started to laugh because, some people were booing at Java and other things. So it's discussion going on. But the most interesting part of me is that when we're extending Python with other languages, now we get for free new people, new cool people, and we're extending our own community. So yeah, now it's your turn. You have all the tools here to just play around, maybe try it once and have a Python extension. And I hope you learned something new today. Thank you very much.